I'm glad to have the opportunity to be here this wonderful Sunday morning. It's bright and early, and one of the earliest things that were under development was hydrogen, the first element of the periodic table, and so that's perfect right for our talk. First off, what is molecular hydrogen? Well, here's the molecule here. It's two hydrogen atoms that are bound together to form the molecule molecular hydrogen. It's the Hindenburg, it's the hydrogen gas. We have talked about hydrogen gas as an alternative energy source for many years, using fuel cells. It's 3 times more energy dense than gasoline. So that's where most of research of hydrogen has been. However, recently, hydrogen gas has been shown to be therapeutic and medicinal. And I came across this whole hydrogen gas area about 6 years ago or so, and I was really astounded. And I wanted to learn more about it, and I started doing more research, reading more articles, just going through everything that I possibly could. I was an undergrad. My degree was biochemistry. I continued reading all these articles. I got more and more excited about it. I did a number of just research projects here and there. And then for my internship to complete my degree in biochemistry, I had the opportunity to go to Nagoya University in Japan. And that was a big deal because Nagoya is the 5th most prestigious university there in Japan. It's very well recognized. And I had the opportunity to go over there and research with some of the brightest minds in the world of academia. And my mentor, Dr. Kinji Ono, he is the vice dean of Nagoya University in the Department of Neurogenetics. And it's very interesting how he got into this whole area of hydrogen gas. And his story is basically he heard a lot of anecdotes and other colleagues talking about this whole hydrogen gas idea and its possibility that it could be medicinal and therapeutic. And he being rather skeptical and a very respected scientist in his field of neurogenetics and all the things he's done for the Mayo Clinic and other places throughout his life, he didn't quite want to do the whole hydrogen gas thing because he was very skeptical and almost sounded a little like pseudoscience or something. And so what he decided to do is do an in-house study where he was going to see the effects of hydrogen gas on Parkinson's disease. So he took rats and injected them with a toxin to induce a Parkinson's disease in them. And then he had, in a controlled trial, he had some of the rats drink water that contains dissolved hydrogen gas, and of course the other rats just drink normal water. What he saw changed his research career because he saw that the rats drinking the hydrogen-rich water, it totally prevented the development of Parkinson's disease. So when he saw that with his own eyes in his own lab, that totally changed research career, and now he is focused entirely on trying to elucidate what the underlying molecular mechanisms and primary targets of hydrogen gas is. And that's also my primary desire or goal or emphasis, is what interests me the most, is how is hydrogen gas working? Because we see it in cells, tissues, animals, humans, all these different things about hydrogen gas, but the question is, how is it actually working? And those answers remain elusive. So in this presentation, I'm just going to briefly give you an overview of hydrogen gas and its medical applications, what we've seen so far, how it can be used, and that should help you in your practice and how maybe you can use it. So here's some of my objectives here. We're basically the basic pharmacodynamics of hydrogen gas, including its role as an antioxidant and its signaling and modulating effects, therapeutic and potential of molecular hydrogen in medical and clinical applications, and the shortcomings and weaknesses of conventional antioxidants and how hydrogen gas can overcome them. So right now, molecular hydrogen has shown to have therapeutic potential in over 150 human and animal disease models. The last count is actually closer to 170 different human and animal disease models. And essentially every organ of the human body, the spleen, the pancreas, the brain, the heart, the testes, the placenta, and we'll talk about more of these in detail. The number of research articles on molecular hydrogen are also growing exponentially. It really started about 2007. And the reason why is because, there's lots of journals and more popping up these days. But journals, as you know, in the peer review are tiered at higher levels, and this is generally based on its impact factor. In 2007, there were about 50 articles that were published on the medical effects of hydrogen gas and its potential as being therapeutic, but no one really took a lot of interest. One of the first articles was in 1975 by Baylor University and Texas A&M, showing that hyperbaric hydrogen has a marked regression of tumors, melanoma tumors in mice. And there's a couple other articles here and there, but not a lot of interest. And really, when you think about it, how do you really apply hyperbaric hydrogen to normal patients? Hydrogen gas is extremely flammable. It's a safety issue. So it wasn't really practical. However, what happened, there were only 50 articles or so around 2007, but in 2007 there was a groundbreaking article published in the journal Nature Medicine, which, as you know, is one of the most prestigious, highly respected journals. It has an impact factor around 30 or so. And when the article was published in there, which has been cited hundreds and hundreds of times, that really took the biomedical research area and scientists by surprise, and now research has just grown exponentially to now there's actually around 600 different articles that discuss its therapeutic application. It's not just in Asia, but also here it's growing in the U.S. A number of these universities and organizations are also doing hydrogen research. You see NASA, some of them are actually looking into using hydrogen-rich water. You can take the gas and put it into water, and astronauts can drink that to protect them from the radiation damage during space travel. So lots of easy uses. Loma Linda University, this is an article that was published in 2013 by Dixon and colleagues. They say that hydrogen has marked therapeutic potential to help with the top 8 out of the 10 fatality-causing diseases listed by the CDC. It's remarkable what we're finding so far. So the question then is, how does hydrogen exert these biological effects? Like I said, it has this therapeutic potential in essentially every organ of the human body, but how? How's it doing that, right? Well, one of the hypotheses or theories that we've found so far is that hydrogen neutralizes toxic radicals as a therapeutic antioxidant. And this, again, is in 2007. This is the article that I mentioned earlier that was published in Nature Medicine. You can read the title, Hydrogen Acts as an Antioxidant by Selectively Reducing Cytotoxic Hydroxyl Radicals. And so they made of course, hydroxyl radicals via the Fenton reaction against C reduction. And it was very, very, very profound what they were able to see. But note the word selective, because we're going to talk about that. First off, what are free radicals? Just so we understand, these are free radicals have the unpaired electron. They're very reactive. Then you also have the reactive oxygen species like hydrogen peroxide, and a number of other ones that are just very strong oxidants that can cause damage, which, as you see here, they can damage RNA, DNA, protein, cell membranes, linked to cell death, and really every disease there is, neurological disorders, inflammatory disorders, cancer, diabetes, and the list goes on and on. How are these reactive oxygen species generated? Primarily in the mitochondria, primarily complex 1 and complex 3, the electron transport chain. You have oxygen reduction to superoxide, and then, of course, that can go on to form hydrogen peroxide, hydroxyl radicals, and other oxidants and pro-oxidants, which cause all these damage. But notice, most of that is in the mitochondria inside of the cell. Now, importantly, the body, as you know, has our own self-defense system. We need oxygen to breathe. I mean, how many of you are breathing right now? Well, you're doing it because you need it. And every time you breathe oxygen, though, around 2 to 4% of that oxygen can actually turn into these cytotoxic oxygen radicals that can in turn be damaging to your body. So we have to protect our bodies from this. So we have various peptides and enzymes to help protect our bodies. As you know, things like glutathione, superoxide dismutase, catalase, and a number of other things. What we're showing, though, is life, in reality, is balanced between oxidation and reduction. I mean, you can even consider it like a battery, a negative and positive charge. Life is totally balanced on this. On the one side, you have oxidation. You have all your different things from your hypochlorite, your hydrogen peroxide, superoxide, and your NAD+, NADP+, all of these different things are just all oxidants that the body needs. And then on the other side, you have reduction. And the whole body, everything, is balanced right between this. Or you can have oxidative stress or reductive stress. And it's interesting, the molecules that seem to characterize oxidation reduction the most is actually oxygen and hydrogen. And when the two react together, you form the life-giving solvent water. So it's kind of a romantic story when you consider all this, and the fact that we've been focusing on oxygen all the time, but maybe missing this yin and yang type of relationship with the hydrogen. And now the research is coming back in saying, hey, this hydrogen is actually fairly good for us. When via aging and certain diseases, toxins, some of these things may actually lower our body's own antioxidant self-defense system. So maybe we're going to have lower glutathione levels or lower catalase levels or different things. Now we're going to have an excessive amount of oxidative stress in the brain, the liver, or other organs of the body causing various diseases. Now, importantly, please note this. This is a misconception that all free radicals are just toxic, bad, kill you. Take 1 million loads of antioxidants and you're just going to live forever. This is important because free radicals, or reactive oxygen species, are very important signaling molecules. You see they're important for signal transduction. Here's a little pathway you can memorize, and you'll be tested on it later. It's important for immunity, vasodilation, nitric oxide. People talk nitroglycerin, Viagra. All of these things are all about nitric oxide. Well, you realize nitric oxide is a free radical. What a shame would it be for all of us if we neutralized nitric oxide. We lose a lot of benefits. Also, the activation of transcription factors. So, importantly, like I said, life is balanced between oxidation and reduction. We have to keep that balance. Now consider this. This is a review article. Perhaps this is why clinical trials with supplemental antioxidants often have deleterious effects. As this review article clearly states, antioxidant supplements do not possess preventive effects and may be harmful with unwanted consequences to our health. Now, please note there are certain cases where high doses of maybe vitamin C here or glutathione there, this or that, can be very effective, but in the right circumstances, in the right cases, and really a case-by-case basis. But when you really look at the literature, you'll see that for most of the part, when you're taking high levels of antioxidants, it doesn't really offer the benefits you think it ought. And there's a few reasons why. One of them, maybe it's scavenging too much of it, and maybe it's not actually getting to where it needs to be in the first place. Exercise. We know exercise is medicine. That has been the cry of this last few years. Exercise is medicine. Well, guess what? When you exercise, you're breathing more oxygen. Unless you hold your breath when you breathe, and I wouldn't recommend that. Although you do get winded faster. The fact is, when you exercise, you produce more free radicals, and these free radicals, reactive oxygen species, are very important for your training benefits. Increased mitochondrial biogenesis, increased vascularization. All of these different things really can be mediated by these free radicals. And guess what? Conventional antioxidants may actually negate the benefits of exercise training. They've shown studies of people taking high doses of vitamin C, for example, that can blunt the improved insulin sensitivity after a bout of exercise. Or maybe a 10-week exercise program with endurance training. Well, all of a sudden, they don't have a higher VO2 max, or they don't have as much of a mitochondrial biogenesis as they ought to have because they're taking so much antioxidants. So all of these things are very important to consider with patients with chronic diseases who may be suffering in their cells oxidative stress. Consider this, that in the cell, there's a new article published, I think in Science, that showed that you can have a cell that in one compartment, say the endoplasmic reticulum, which, that's important, the ER is important for protein folding, right? And protein misfolding is like, what is the cause of aging and everything? Well, guess what? As you age, the ER, the endoplasmic reticulum, actually loses its stability, its oxidative power, its oxidative potential. It doesn't have enough because there's not as much oxidative potential. So again, we have to have that oxidative potential. So in the ER, we're having not enough oxidative potential, but in the cytosol, we're having too much oxidative potential. So in the exact same cell, we're having a dysregulation of redox homeostasis. See the issue? So the question you all have is, well then, Tyler, why are you trying to talk about hydrogen gas as an antioxidant if antioxidants aren't so good for us? Well, that's a good question. Let me answer that. First off, notice the article. It's selective. Selective antioxidant. It's really only going to scavenge the most cytotoxic or cell-damaging free radicals, such as the hydroxyl radical. Okay? All these other ones, superoxide, anion radical, look, that's not very reactive. And it's going to be regulated by the body. It has and superoxide just mutates. That'll just mutate that to form hydrogen peroxide, and then you have hydrogen peroxide. Well, that's not very reactive either, and there's actually aquaporin channels that hydrogen peroxide goes into, does signaling things, and then catalase of glutathione peroxidase takes care of that. All of these things are regulated and controlled by the body. Hydroxyl radicals, on the other hand, are produced and just kill. Produce and kill. That's what they do. That's why they live and die. They die killing you. So let's not do that. Let's scavenge those things with hydrogen gas. And this is the other thing. Even if we're scavenging maybe too much hydroxyl radicals, let's do some physics, some chemistry here. Look at the rate constants. Typical radical reactions are on the order of 10 to the 10th. You see the hydroxyl radicals to form hydrogen peroxide, 10 to the 10th. The rate constant of all these ones are about 10 to the 10th. Notice the last one. Hydrogen gas against the hydroxyl radical is 10 to the 7th. 3 orders of magnitude lower. And plus, the concentration of hydrogen gas in the cells is often very low, the micromolar amount. So even at that, you're not going to be scavenging an excessive amount of these important biological signaling molecules. But it can do it under the right circumstances, such as when there's oxidative stress. Not just oxidative things going on, because again, that's key and essential to our whole being. Now, this is a very important slide. And I'm going to talk about each one of these points. Please note what hydrogen gas is and how it's more beneficial than your conventional antioxidants. First off, we have rapid diffusion. Hydrogen gas is the highest diffusivity of all gases, really of anything. Okay? Consider the fact that it's the smallest molecule in the universe. It's just 2 hydrogen atoms, 2 electrons and 2 protons. It's neutral, so therefore it's hydrophobic. Well, we know that if it's hydrophobic or neutral, it's going to be able to get through the cell membranes very easily, as opposed to other antioxidants that maybe are lipophilic. And there's no byproduct, it's just water. As you know, the hydrogen gas reacts to hydroxyl radicals, and the byproduct is water. We're going to talk about that in a little more detail. Let's look at this slide here. We have the big red thing there, that's the hydroxyl radical, and then we have the little blue dot, that's hydrogen gas. Notice where those big bang little red things are. Those are inside of the cell, the nucleus, the mitochondria. Okay, that's where those are at. So that's where we have to get those antioxidants. Well, let's look at the blue diamond. Those are hydrophobic antioxidants. If they're hydrophobic, they're fat soluble. Therefore, it's going to be a little harder for them to get in the cytosol of the cell, where it's more of this aqueous water-soluble things, so the things like vitamin E, that's going to be where? In the cell membrane. It's not going to want to go into, say, the nucleus or go all the way into the mitochondria. You see the problems? So therefore, it's not really going to get to where these hydroxyl radicals are being produced in complex 1 or 3 or in the TCA cycle of succinate dehydrogenase or things. The other problem is hydrophilic antioxidants. Okay, so how are you going to go through the cell membrane? Because remember, that's made out of fats. Well, now we have to have various transporters and all these different things. It changes the whole rate constants of getting the vitamins to the radicals where the problems are actually taking place. So now maybe we can see how we're causing reductive stress in some places and a continuation of oxidative stress in other compartments. Whereas hydrogen gas, smallest molecule. It's hydrophobic, it's neutral. So it can diffuse through all these subcellular compartments and membranes, the blood-brain barrier, testis barrier, placental barrier, all these things very easily, where it can actually react with these hydroxyl radicals and convert them to water, which is, the last thing, that's the byproduct is water. Think about it. When you have something like vitamin C, if vitamin C donates its electrons, it's not vitamin C anymore. It's an oxidized form, right? And so now the body has to rejuvenate that, which is going to be use up NADPH equivalents or glutathione or other things. It's got to metabolize it. It's got to eliminate it. It's got to do something, or else now that could be a potential toxic pro-oxidant or of some byproduct or whatever. The body's got to clear it, right? Versus hydrogen gas, it's going to react to these hydroxyl radicals, and the byproduct is simply water. I mean, some people even drink that stuff. Now, importantly, though, hydrogen gas does reduce oxidative stress, because we're talking about all these things about why hydrogen gas is selectivity, the rate constants. Well, then, does it really work? And what I did is, like I said, there's over 600 articles now. I've read every single one of them. and I've gone through and I've done all this stuff, and I just took some of the neat things and I kind of prepared this table. So here we see markers of oxidative stress. This table comes from cells, from tissues studies, from animal studies, and human studies. And this is where hydrogen gas can do its thing in the right conditions, in the right cases. Remember, if you have normal MDA levels, which is malondialdehyde, which is a marker of oxidative stress, hydrogen gas is not going to reduce it. It's not going to do it because it's a mild reductant, and you don't want to reduce oxidative stress more than you need to, okay? So markers of oxidative stress, these are very common markers. MDA, T-bars, 8-OD-HDG, the marker of DNA damage, all these different ones, hydrogen gas showing it can reduce oxidative stress. On the other side, check that out, markers of antioxidant status. Hydrogen gas actually able to increase or upregulate to bring back to homeostasis our body's own antioxidant enzymes such as superoxide dismutase, glutathione, catalase, glutathione peroxidase, glutathione S-transferase, glutathione reductase. All of these things hydrogen gas also helps to do, which we'll talk about here in a little bit as well. Now, there are 3 ways hydrogen gas is able to do this to reduce the oxidative stress. One of them, as I said before, hydrogen gas may actually be scavenging these hydroxyl radicals, as is shown in the Nature article, and again, you form water. Another one is hydrogen gas can actually activate what's called the NRF2 or NRF2 pathway, which is it's a transcription factor, right? The whole antioxidant response element part of the DNA. Hydrogen gas can activate the NRF2 pathway, which leads to an increased production of superoxide dismutase, glutathione, catalase, and subsequent induction of heme-1 oxygenase, which again is extremely cytoprotective. And somehow that does it. Notice I have a question mark. That is what intrigues me. I want to know, how is it doing that? Okay, what is the primary target? Some kind of iron sulfur cluster here, and it's going to, or cell membrane volume type thing, it's going to attach to that and do its little magic. It's amazing, you know. I was at Nagoya for a few months doing research there, and so I was able to actually research some of these signaling pathways and whatnot, and seeing how hydrogen gas is actually changing the different levels. And I'm like, okay, how's it doing it? How is this doing it? It's mind-boggling. It's awesome. Okay, so going on, hydrogen may also prevent this excessive amounts of reactive oxygen species by actually preventing them from forming in the first place via cell modulation. Here we have like a NOx system, NADPH oxidase. On the one side we see it's activated. When it's activated, the complex is glued together. It's not really glue, super glue, you know, we don't have that in our cells. But for the sake of this, they're stuck together, and when it's activated like that, we're reducing oxygen to form superoxide, and the superoxide can go on to form various other radicals that are very damaging. And when that's heightened, when that's activated via inflammation or various pathologies or diseases, we're going to have more and more oxidative stress, maybe reductive stress somewhere else, and the whole, again, dysregulation of redox homeostasis. Well, hydrogen gas, in the right circumstances, can actually downregulate this NADPH oxidase system, thus preventing ROS formation in the first place. Now, don't we say prevention is better than better than treatment? Well, here's hydrogen. It's a smart guy. You know, it's simple, humble, but you know, it's doing what it does best. Now, importantly, though, the antioxidant activity may not fully answer why H2 has so many benefits, because the fact is, when you take hydrogen gas, well, you're going to exhale most of it out of your breath. It's not going to be in your system for, you know, days and hours and whatnot. It's going to be cleared very rapidly. So why isn't then you can take hydrogen gas through, you know, drinking hydrogen-rich water or inhalation or something, and yet still have these cytoprotective effects hours or even days later, this residual effect? Because if hydrogen gas is not even in the cell, then how is it scavenging those hydroxyl radicals, right? So there has to be something more to this. And this is, again, where I get really excited, so bear with me if I start doing, you know, jumping up and down. First off, H2 may actually acting as some sort of novel signaling molecule. And the reason why is because under the right conditions, hydrogen can alter the levels of activities of over 200 different biomolecules. I got 200 biomolecules. I just went through a bunch of articles, and I'm like, okay, that's a transcription factor, that's a protein, and this is not mRNA, remember, because you do, you know, RT-PCR or something, you have different, you know, mRNA levels or whatnot. That doesn't actually account to like your Western blot of an actual protein. So these are all things that have been altered on the protein level, which is what matters. And hydrogen gas is able to upregulate or to downregulate over 200 of these different things. How? I don't know. But when you compare this hydrogen gas, because it is a gas, to other gaseous acetylene molecules, and this is very interesting. Let's talk about nitric oxide. Nitric oxide, it was a acetylene molecule, but before that, in the 80s or 70s, and this time, they knew that there was this vasodilating active thing. It's called endothelial vasodilator, and they didn't know what it was. They just knew it was some agent. Somebody proposed that it was a gas, nitric oxide, and what happened? He got laughed at, and he ridiculed and everything, because the gas can't do that. Nitric oxide, no way, no way. And guess who won the Nobel Prize, right? 1998, he got the Nobel Prize for showing that, yes, indeed, it was a gas that was doing this. And subsequently, he found other gas acetylene molecules, such as carbon monoxide, which is very toxic at high levels, but extremely therapeutic in lower doses. And our body actually makes carbon monoxide through a heme-1 and different things. But we see here, this is my little graph I prepared for you. If this is why it's so elusive when you consider hydrogen sulfide. You can see the chemical structure. It's polar. We know the mechanisms, S-sulfhydration, protein, the cysteine, etc. We have nitric oxide. Well, it's very polar. It's a radical. And we know its mechanism, nitrosylation. It binds to the iron on the guanylyl cyclase. Carbon monoxide, one of the targets like hypoxia, disciple factor 1 alpha, heme 1 oxygenase. We see these mechanisms, we see the chemical structure, how it's going to interact with these different moieties of the cell or different things. However, hydrogen gas is nonpolar. It's neutral. So how is it working? What are the mechanisms? And as you can see there, that's how it's working. These question marks. So when you have a very good microscope and you look in there, you start to see these question marks in there. And that's what I feel like sometimes. So really, this is what it is. How is hydrogen gas doing this? Who knows how many pathways or whatever it's doing, or maybe it's just master regulators and drivers that are then in turn inducing all these things. So hydrogen gas is altering these things indirectly, not directly. Which ones that are affecting directly, I don't know. We're getting closer. And I just had a talk with a Japanese scientist a few days ago. We talked over 2 hours, and he has some studies he's been doing. We can't disclose it at this point, but we're getting closer, and it's exciting. I'm getting ready to jump a little bit, so I'll just move on before. Okay, so the fact is, we know that hydrogen gas is working. We've seen tons of studies. It's awesome. It's amazing. We know we don't know how it is working, and I have an idea. Maybe it's a romantic story, and we like romance and stuff. So I decided to give. Well, maybe here's the reason why it's working, and here it is. Perhaps the reason H2 exerts a biological effect is because H2 has been intimately, see, it's romantic, intimately involved in the origins of the universe, the genesis of life, and the evolution of eukaryotes, so your plant animal cells. Check it out. So, at the very beginning, hydrogen was involved in the origins of the universe. And one of the famous astronomers, Harlow or something, he said, if God did make the world in one day, that word would have been hydrogen. I just thought that was interesting when you consider this whole thing about hydrogen. It is the father of all the elements. The Big Bang 14 billion years ago, and then we get hydrogen and all the other molecules that are elements of the periodic table. So we should thank hydrogen for that. Then we have the next part. Hydrogen was involved in the genesis of life. We even go back to the famous Stanley Miller experience in science back in 1953. Hydrogen gas is one of those molecules there that was involved in the production of the various base molecules of life. And the hydrogen gas could come from this, reaction with iron, hydrogen sulfide, form hydrogen gas. We have this picture here, which is also shown here. Deep-sea hydrothermal vents from the ocean, where life likely originated from, will actually may have served as an energy source to these chemolithic autotrophs. That hydrogen gas has these electrons, is very energy-rich, so these enzyme complex, whatever, eventually could develop the ability to extract those electrons out, this hydrogenase activity, forming the first life, the first types of prokaryotes and whatnot. And very interesting, an article in Science in 1975 said, the last common ancestor of life also metabolized hydrogen for energy, thus again suggesting its involvement in this entire evolutionary process. This is interesting. Many of us have heard of these, natural healing waters and all this kind of hocus-pocus stuff. Actually, some of these waters, though, have been documented to have potential therapeutic benefits. And when you go back to the waters, and some scientists have gone back there, and they've actually tested these waters to see what's in them, and guess what they found? Hydrogen gas. Now, hydrogen gas could be in the waters via maybe anaerobic bacteria or basalt catalyzed reaction from the various metals in the water, but some of these waters contain small amounts of hydrogen gas. So it's pretty interesting. And now, let's talk about how natural or safe hydrogen gas is just for a little bit. The fact is, every time we eat our fiber and our meals and our foods and vegetables, the bacteria in our intestines, and you know the story, bacteria is like extremely important. It's like been going on for decades now about how important the bacteria is for us with microflora. One of the reasons why is because of when you eat your fruits and vegetables or fiber, non-digestible carbohydrates, you're producing hydrogen gas, and you're getting as much as 10 liters of H2 per day, and you have a higher breath ppm. And so therefore you have micromolar levels of hydrogen gas. So therefore you have a basal level of hydrogen gas in your blood since the dawn of time, if you were alive back then. Now, this is so hydrogen gas from your bacteria does indeed have a therapeutic effect. In fact, in 1988, based upon the redox potentials on the Nernst equation, hydrogen gas was suggested to be an antioxidant from the bacteria. And in 2009, it was confirmed by a report from the Forsyth Institute in Boston, Massachusetts, and the University of Florida. This is an awesome study. All they did is they took these, it was just rodents or rats, and they of course had bacteria, the E. coli with what's called the hydrogenase enzyme that could produce hydrogen gas. And when they give lactulose, which is a non-digestible carbohydrate, the bacteria metabolizes that lactulose, produces an obscene amount of hydrogen gas, and all these benefits are seen, protection to the liver. Well, they took the E. coli, they did a genetic knockout, so they removed the genes that produces the hydrogenase, they put the bacteria back into the rats, and then they gave lactulose. So now the bacteria still has the rats, the bacteria has the rats, that would be interesting. The rats have the bacteria, and they give the fiber to them. So you'd think, okay, they still got the bacteria, so things should be fine, and guess what? The therapeutic benefits are like negated, eliminated, gone. It's like, oh, that's interesting. Well, when they put bacteria back in that had the hydrogenase enzyme and gave it lactulose, all those benefits were reinstated, thus suggesting that, again, hydrogen gas is maybe a primary method or reason of why fiber is so good for us. Okay? This is crazy. This is awesome. This is from the NICS publication of Physical Letters, Chemistry Letters. This is a hypothesis based upon some physics and whatnot, but actually resveratrol, we've heard about it, is very good for us. Nobody really knows the exact molecular mechanisms of why or how it works, but there was an article that suggests that maybe the benefits of resveratrol are actually mediated by the production of hydrogen gas, because in the mitochondria you have electron leak, and the electron leak can donate electron to parts of the polyphenol groups of the resveratrol, and then you have dissociated electron attachment, and therefore you have production of hydrogen gas, which can then go and scavenge hydroxyl radicals right there where they're being formed. So, and there's a number of other articles that are coming out saying, well, then that's the case, and this one could work too, because you do the calculations, and then, hey, this makes sense. So again, this is kind of groundbreaking stuff here. So method of administration, we have, of course, you do hydrogen-rich saline, so you have saline, and you have it's full of hydrogen gas in there, and they've done studies on that. Ingestion of hydrogen-rich water, where you can simply bubble hydrogen gas into the water, which isn't too practical. There's methods to get it via electrolysis. They have hydrogen-producing tablets. They're made of metallic magnesium, so not like a magnesium chloride or something, but an actual metallic magnesium that reacts with the water to form magnesium hydroxide and hydrogen gas. And many people have been using that with remarkable benefits. Well, they put the tablet in the water, and people can do like a 1 tablet a day daily maintenance. And for you practitioners, if you have looking for somebody with pathologies or whatnot, they can take another 1 or 2 or 3 or 4. The DRI of magnesium is 500 milligrams, and most of these tablets contain around 50-55 milligrams of magnesium or so. So you just put it in the water. If it effervesces, produces a ton of hydrogen gas, and the patient can drink that, and you start seeing a lot of benefits. So it's pretty easy to administration. And then, of course, there's inhalation of hydrogen gas. You know who that handsome guy is? Not that he's handsome, but who's judging? But it is me. I lectured I gave a talk in Beijing at the Biomedical Hydrogen Symposium No, actually, I was there earlier in Shanghai. That's where this was taken at. I was meeting just with the company. They wanted to talk about hydrogen research and different things. And they have this machine. This is a big daddy, you know. And they have these various medical clinics there in China, and people go in there and they inhale the hydrogen gas. And it's amazing the things that they have found. They've collected over 20,000 patients worth of data, case study after case study after case study. I met a woman. I saw a video of her first, and the whole thing about her. But then I actually met her when I went to do my inhalation therapy. Because I'm actually 55 years old, if you didn't know, but I've been doing hydrogen for a while. So when I went to do I went to do this inhalation, and I got to meet her. And what happened with her is she got a stroke. That's the unfortunate part, but there's good news. She had the stroke. They had the brain imaging, and it was just totally messed up. She was actually paralyzed like a lot in her left side of her body. Couldn't really move her left hand. Couldn't walk, or do very much stuff. She immediately started hydrogen inhalation, and within a few days later that week, she regained mobility back. She could walk up the stairs all by herself. She could move her left arm. And there's case after case after case of people who are like in a coma, ready to die, take them off oxygen, all of a sudden put them on hydrogen inhalation therapy, and they wake up a few hours later, start doing better. I mean, it's just like, I don't even believe this stuff, but it's like right here, and there's so much empirical evidence. I'm like, okay, this is awesome. I believe the Chinese FDA just gave the FDA clearance, the medical approval, so they can sell to medical hospitals there in China. So it's enormous, all the amount of research, things that are going on at very high levels. Now let's go to just some of the studies so you can see what are the studies actually showing. First I wanted to compare the superiority of hydrogen to other antioxidants. Here we have the long-term treatment of hydrogen saline abates testicular oxidative stress induced by nicotine in mice. It's an epidemic. People using tobacco, smoking, and that causes testicle problems. And if you want those and save them, then this is a good option for you. If we compare this to other antioxidants, so this is very powerful. On this far graph, we have T, which stands for Tyler. No, it stands for testosterone. First we have the control, and that's the normal range you want to be at. And then you have no treatment, right? But you get the nicotine, and you notice that just plummets it right down. It's like, it's like you always see these things, and they always get stars. I'm like, that's like contradictory, because when I was in school, I got stars when I did good things. So, just kidding. So it plummets that right down. And then when they give hydrogen gas, it just brings it back up, and no star for you. It maintains that hydrogen gas, the testosterone levels right where they need to be, but when you gave vitamin C or vitamin E, there was no statistical improvements. Same thing with sperm motility and sperm concentration. Again, it was a hydrogen gas showed the superiority of this. A similar finding was found with the effects of vitamin C and vitamin E and hydrogen on the placental function in tropoblasts. So people like preeclampsia, for example, the hydrogen gas was shown to have a beneficial effect on HCG, where vitamin C and vitamin E did a little bit as well. However, if you look at you can go and look at this article, but it was shown that vitamin C and vitamin E actually suppressed cell viability, so they're like not living as well, and increased immune responses, tumor necrosis factor alpha, and other problems. Whereas hydrogen gas didn't have any of those side effects; it just had a beneficial effect on HCG. This is very interesting because radiation is a big talk. All the damages come from this. I mentioned like NASA with the astronauts. That's an interesting concept. Here we're showing the concentrations of 8-OHDG, which, as I mentioned, was a marker of DNA damage. This is really cool. When you look at this first graph, there's where you have a marker. You're about 0.7 or so. When you give, that's where normal people, right? There's no hydrogen gas is given, this is actually an animal model, but no hydrogen gas is given, no radiation is given, and that's the normal level, if you will, of that marker, right? So you always have just like small amounts of inflammation, that you need to have a little bit of this. So that's where that was. When you gave hydrogen gas and no radiation, look how much hydrogen gas affected that. Not really anything at all. Do you see the benefit in that? You notice when you take like maybe other pharmaceuticals or drugs or just different things, and then that just is going to go in there and just decrease it, or increase it. Well, that could be bad because we want to maintain homeostasis. Hydrogen gas really doesn't perturb homeostasis. If it's where it needs to be, it's going to stay there. And that actually is one of the reasons why hydrogen gas is so difficult to study. With many drugs or things you can take your cell, you throw the drug or the compound in there, and then you can do your study, and you can see how that affected the cell in your in vitro system or something. Whereas with hydrogen gas, it's a little more complicated because you can't as easily do that. You almost have to induce some sort of toxin or some assault to it or something, and then see how hydrogen gas attenuated or mitigated those effects. So you have all of these more variables to look at, because hydrogen gas really does not dysregulate or perturb the normal homeostasis. It's not going to reduce things when it should not be, and because of those things, that is why one of the reasons why it's difficult to study the molecular mechanisms of hydrogen gas. But importantly, this is what you really want to know, is that really big graph there. That's when you gave the radiation. So now we have tons of DNA damage, and the person's dying. It's probably already dead. But when you gave the hydrogen gas, you see it just decreased that very significantly. There's this hydrogen gas really has a very wide breadth of uses, of course, for athletes as well. Here's a pilot study on the effects of drinking hydrogen-rich water on muscle fatigue caused by acute exercise in elite athletes. This is very interesting. They showed, they had the beneficial on the fatigue. They showed less lactic acid or lactate. There's not really lactic acid, the myth thing. We don't need to get into that. But the thing is, they showed a decrease in lactate. Not that lactate is bad, but what that shows is, remember, when you make ATP, you use the glycolysis, or you use the mitochondria through the electron transport chain. Mitochondria produces a lot more ATP. When you're exercising really hard, you start producing all these free radicals. All those free radicals can make damage to the mitochondria, compromise it. Now you have less ATP out of your mitochondria, so maybe you need to start relying more on glycolysis. And so now you're going to start producing more acid via hydrolysis of ATP and glyceraldehyde 3-phosphate and different things. Now your acid is going to increase, different things are going to happen, and now you have more lactate is going to be produced. This whole lactic acid, but it's really lactate, is going to be produced, and that's what you see. So what hydrogen gas is showing, that there's not as much lactate production. That may be because hydrogen gas may actually be stimulating the mitochondria and protecting it from being damaged. So now you can maintain normal ATP levels. Now you can still rely on your mitochondria for your ATP needs instead of the glycolysis. And of course, when you consider the fact that how important ATP is for everything, ATP, as you know, is the energy currency of the cell. If you put the needs of the ATP in what we really need, you need about the same pounds of ATP that you weigh. So if you weigh 150 pounds, you need about 150 pounds of ATP per day. That's how much is resynthesized in your millions and millions of mitochondria and your cells. That's a lot. And a serious athlete who's doing like a marathon or something, they may need twice that ATP, so up to 300 pounds of ATP. Okay, so the mitochondria plays a very large role, and so being able to protect the mitochondria is extremely important. And in fact, that's what we see here. H2 stimulates mitochondrial function. This is an allograft, cardiac allograft article, but it's very good graphs. We wanted to show this. Complex 1, 2, 3, and 4, and 5. All of these things, with the electron transport chain, so hydrogen gas can actually stimulate them. In fact, even beyond control, the control in some cases, which when you stimulate these complexes, you're going to have higher ATP levels, which shows, again, here you see even above control, you have higher ATP levels. Mitochondria does seem to be a major place that hydrogen gas is exerting some of these therapeutic benefits. This is a very powerful study. This is pretty cool. The maternal molecular hydrogen administration ameliorates rat fetal hippocampal damage caused by uteroischemia reperfusion. Okay, so when the mother's delivering the baby, sometimes you can have an IR injury or different things, and that's going to cause a lot of brain damage to the infant, and that could be very very sad and very damaging. So look at these graphs. Here we have the sham, and that means, the delivery went perfect, everything was totally fine. And then you have the IR, the ischemia reperfusion injury, and you notice on the x-axis the degenerated cells are just, very high. They just really go up there because you have this IR injury. Now, then you can have the mother drink the hydrogen-rich water, because you can't really have the baby drink because it's in the stomach, and that'd be kind of awkward. So the mother's actually drinking the hydrogen-rich water, and maybe because, again, hydrogen gas is so small, it can just penetrate the placenta and everything very easily. But look what happened. When the mother drank the hydrogen-rich water and the IR injury was given, it made it as though it's like the IR injury never happened. And when I saw that, I was like, yeah, I don't believe it. But actually, you see the third author, Ono K, that's Kinji Ono, and he's my guy in Nagoya University, and I trust what he does immensely. So I was like, okay, it must be true, but I'm still going to call him on it. It's a remarkable, some of the things that we're finding. This again, I'm going to go through just a couple abstracts. Look at the title a little bit. Hydrogen supplemental air. So again, we have air inhalation. Actually, can reduce the changes of pro-oxidant enzyme and gap junction protein levels after transient global cerebral ischemia in the rat hippocampus. So again, back to the neurological issues. This one here showed had the expression of COX-2 and the connexins and proteins were actually upregulated, while the neural nitric oxide synthase, which can cause a lot of damage if that's too high, was actually downregulated after 3 days after the injury that was given. So hydrogen gas, again, helpful in this area. Molecular hydrogen in drinking water protects against neurodegenerative changes induced by traumatic brain injury. This is from the University of Washington and Wisconsin and a couple organizations. This is an amazing article. It's still kind of difficult to believe, but these are pretty good researchers. But they found that hydrogen gas is really was protective on the mitochondria and the ATP production, and actually they suggested that hydrogen gas could actually increase ATP levels via what's called the Jagendorf reaction, which is interesting. It's in the mitochondria. It doesn't really rely on the electron transport chain. We don't need to go into that, but it's pretty interesting what we're finding here. The oral intake of hydrogen-rich water ameliorated chlorophyllus-induced neurotoxicity in rats. That's just an organophosphate, a normal pesticide, and it's a big deal. Are these pesticides hurting us? All this kind of stuff. And I guess there's some debate about that, but what we see, though, is hydrogen gas can actually offer some protection against the neurotoxicity caused by this stuff. In this article, it did so by activating the acetylcholinesterase activity, which again is difficult to believe because that's already has a very high K-cap. But I actually talked to the researcher who did this when I was in Beijing, and I talked about her results, and she went on about them. She did numerous experiments, and I was like, oh no, but. They're really going after this stuff, and regardless, that was her kind of mechanism of how it's working. Regardless, though, hydrogen gas was protective in this area. Here, hydrogen-rich water protects against ischemic brain injury in rats by regulating calcium buffering proteins. So again, we have this whole brain injuries and things, which again is a huge issue these days. Hydrogen gas very neuroprotective. This is awesome. Hydrogen-rich water ameliorates amyloid beta-induced neurotoxicities like Alzheimer's, for example. This is through the upregulation of SIRT1 FOXO3A by stimulation of AMP-activated protein kinase SNK and MC cells. So that's awesome because, of course, the SIRT1 protein is it's okay. I understand. It's awesome though. Here, hydrogen-rich water improves neurological function through the attenuation of the blood-brain barrier disruption in spontaneously hypertensive-prone rats. So that may be one of the reasons why hydrogen gas is also effective. It can help attenuate the blood-brain barrier, and we know it's a big thing. When you have a disruption in that via hypertension or drugs or what have you, hydrogen gas may be able to ameliorate some of those things. Oral hydrogen water induces neuroprotective ghrelin secretion. Ghrelin, the hunger hormone, right? This is very interesting. You've heard about the benefits of fasting before, the intermittent fasting and different things of this nature. Well, one of the reasons that fasting is beneficial for you is because you increase ghrelin. And ghrelin acts as a second messenger, is extremely protective, neuroprotective, has lots and lots of benefits. So one of the reasons that fasting is good for you is because you have ghrelin. Well, one of the reasons drinking hydrogen-rich water is good for you is because you also enact gastric ghrelin secretion, and that ghrelin in turn acts as a second messenger to go and help different parts of the brain. And actually in the Parkinson's disease studies that I've talked about and I'll talk about again, it was most likely Ghrelin that acted as a second messenger to offer that cytoprotective effect of the substantia nigra even more so than hydrogen gas. So hydrogen gas did so indirectly via the second messenger, Ghrelin. And here it is right here, pilot study of H2 therapy in Parkinson's disease, a randomized double-blind placebo-controlled trial. This is a 48 trial they did, and awesome results. And of course, I've heard of, there's anecdotal case reports with people taking like the hydrogen-producing tablets. They'll put them in the water in people with Parkinson's disease. Often what I would say is it's not going to give a reversal of the Parkinson's, but maybe a better quality of life, maybe decrease the aging that's going to occur, or the downward spiral that generally occurs in Parkinson's disease. However, I've heard quite a few reports now, people who are taking the hydrogen, that they're have the symptoms. You can see they have the symptoms, and then after a few weeks or whatever of them taking the hydrogen, they totally don't even have that anymore, and they wouldn't be diagnosed as having the Parkinson's disease. So I guess in some cases maybe it is possible to have these types of reversals. Hydrogen-rich water enhances the 5-FU, which is a chemotherapy drug, inhibition of colon cancer. This is very powerful. Chemotherapy, widely used. It's very toxic, of course, to cancer cells. Hopefully that's the goal, but also to our cells. And first off, a lot of studies are showing that hydrogen gas can actually protect the negative side effects of various chemotherapy drugs, like renal-induced neurotoxicity, some different things. So hydrogen gas can protect against the negative side effects of drugs like aspirin-induced gastric mucosal injury, chemotherapy. In this study, hydrogen gas actually offered an additive effect of the chemotherapy drug, where this is a colon cancer in rats, but hydrogen gas, when you gave the drug, there was this much effect, and when you gave hydrogen gas and the drug, there was an additive effect, and hydrogen gas alone could help a little bit. And it depends on the cell line of cancer. There's a lot of issues with cancer. That's why it's called cancer. Here, this is pretty powerful here. Consumption of hydrogen-rich water prevents atherosclerosis in polyprotein E knockout mice. So when they have this genetic knockout, they're going to get atherosclerosis very easily. Hydrogen, this is part of the quote here. The authors in the article state when they compared these results to other things, the efficacy of hydrogen water seems to be greater than folic acid, vitamin E, iron, alpha-lipoic acid, and other things in the preventing of this atherosclerosis. So again, very powerful. Now, briefly, again, the safety, it's very well established. In at least all the cases, there's really no known toxicity that we have found so far. I mean, it has been, there's literally hundreds of studies already just on therapeutic applications, but the fact they've used it in deep sea diving since the 1940s to prevent decompression sickness, because normally you get like nitrogen narcosis and whatnot, hydrogen gas is able to prevent that from happening. And then, of course, from our intestinal bacteria, like I said, from the dawn of time, we've been producing hydrogen gas. We have these basal levels of hydrogen gas in our body all the time. So the safety profile of hydrogen gas is enormous, and so the first rule, right, do no harm, and then if something may work, let's try it. So that's why I'm so passionate about hydrogen gas, is because in reality, I can't really think of something that's, I guess, more safe as a supplement that has therapeutic potential than hydrogen gas, and yet has such profound therapeutic potential. So here's a brief summary. Again, therapeutic potential in 150 or over about 170 different disease models and essentially every organ of the human body. Neutralizes the toxic radicals as a selective antioxidant. Upregulates production of the body's own antioxidants when it needs to be. Again, if you already have normal glutathione, it's not going to increase it more because that could be bad. It has possible signal modulating properties, which again is offering these anti-diabetic, anti-apoptotic, all these different things. In fact, there's one article published in Nature Publishing Group in the Journal of Obesity showing that hydrogen gas could activate the fibroblast growth hormone 21, which induces energy expenditure for like weight loss and things. They found that it was in a mice study, but they found, I think it was rats drinking a hydrogen-rich water had about the same effect as a 15% caloric restriction. And then there was an additive effect when you did both of them. So hydrogen seems to mimic fasting. Well, we already talked about Ghrelin. That's again fasting, so it's pretty powerful there too. Has a very high safety profile. Many easy methods of administration. Probably the easiest, of course, is just drinking hydrogen-rich water. Briefly, because I know the question is there, is what's more effective, inhalation or hydrogen-rich water? Well, it depends. Sometimes inhalation can be more effective, but most of the time, well, I don't know most of the time, but I'll say it for right now, but I might change tomorrow. Drinking hydrogen-rich water is just as effective and sometimes more effective. In fact, in a Parkinson's disease study, only the hydrogen-rich water was effective, whereas a continuous administration of hydrogen inhalation was not effective, and that could be to the need of an intermittent or pulse type of exposure as opposed to this continuous exposure. So drinking hydrogen-rich water, of course, is the easiest and is a very effective way of getting the hydrogen gas. So this is kind of my prediction. The market is generally 10 years behind the science. That's kind of what we see in like a lot of different things out there. So 2007 is really the beginning of focused research on hydrogen. So I kind of predict by 2017 will be the year of H2 awareness, where just more of the universities and people will be like, wow, let's use this, let's do clinical trials. There's a lot of clinical trials that are underway or starting right now, mainly in Asia. And so when those get published, I mean, it's just going to really just take off. So here's some references. You can write these down really quick. So join the Hydrogen Revolution. This is again, the nonprofit foundation, Molecular Hydrogen Foundation. We only have like 2 minutes left. So if there are like a question or two, you can answer them. Of course, I will be out there at a table, and I'll answer all of your questions there. So thank you very much for your time, and I had a pleasure being here.